Hey everybody, this is Gregory from Dapp University. So welcome back to the multi-part tutorial where I'm showing you how to create your own cryptocurrency and ICO on Ethereum. In this video, we're going to be continuing working on our token contract for Dapp token. In the last video, we built out the transfer function. Today, we're going to add a few more pieces of functionality that are required by the ERC-20 standard. So if you haven't seen those previous videos, be sure to check those out. They'll be kind of required in order to continue on with this tutorial. And if you'd like to pick up the code along this point in the tutorial, check the GitHub link down in the description below. And also be sure to subscribe to the channel and turn on notifications with the bell below so that you can get notified about the other videos in this series when they come out. So if you're picking up at this point in the tutorial, we can do a couple things just to make sure that we're good to go to continue working on our project. We will first, ensure that Ganache is running, and it looks like it is, and we have, some Ether in our accounts. So we'll minimize that. We'll also run our tests to ensure that our contracts are working as expected. All right, test pass. So in the last video, we worked on this transfer function, and this allowed, an address to transfer Dapp tokens, the token that we're working on in this contract. It allowed the address to transfer tokens from their account to someone else. Basically, it allowed them to send tokens. And this was all, done on their behalf. Basically, an address would... this is how they would basically spend the tokens, right? Now, the next thing that we want to do for the ERC-20 standard is implement, a few functions that handle transfers where the account did not initially initiate the transfer. And this can be referred to as a delegated transfer. So we want to implement two functions that we can take a look at in the ERC-20 standard. Actually three, but we'll write two here, and we'll kind of automatically generate one with Solidity by declaring another public variable, and we'll see that in a second. So we want to handle delegated transfers. We basically, it's going to be a two-step process. One function is going to allow our account to approve a transfer, and another function is actually going to handle the delegated transfer. It's actually going to, seal a transfer from, one account to another without the sender initiating the transaction. Now, also, I should mention that the next little bit of functionality that we're building out won't actually be used in our token sale. But part of this tutorial is to show you how to build a complete ERC-20 token. And if you remember, the standard that we've been reading through, has a list of required functionality in order for our token to be compliant with this standard. And that's what we're building out here. So let's take a look at the next level of functionality that we want to build out for this token to handle this delegated transfer. There are a few things. The first thing is, well, I'll just take a look. We want to implement a transfer from, an approve function, and an allowance. Okay? So we'll step through these kind of one by one and kind of explain what they do. So without just reading off what's here, from a high level, approve is essentially going to allow someone to approve another account to spend tokens on their behalf. So if I were to call this function, I could say that, my account A approves account B to spend, C amount of tokens on my behalf, and that C would be Dapp tokens. So an example of how you might use something like approve would be on an exchange, right? So you put a limit order in that would say, I want X amount of tokens to be sold. And, the exchange, you're basically approving the exchange to transfer X tokens on your behalf. The transfer from function would actually handle that transfer. So once you have approved a certain amount, the third party address, address B, can actually execute that transfer. So once we've approved it, this is someone else basically calling a transfer on our behalf. And it's a lot like this transfer function we built out in the last video, but the transfer function in the last video, we are always calling our own transfers on our own behalf, and the transfer from is, a third party or calling transfers on our behalf, or this delegated transfer that I mentioned a minute ago. And the other thing we want to build out is this allowance. And this allowance is basically the allotted amount that we have approved to transfer. So going back to the example I said a minute ago, if I'm account A and I approve account B to spend, X tokens, or sorry, C tokens on my behalf, C Dapp tokens, that amount gets stored in this allowance. So if I say, account A, or if I'm account A and I approve account B to spend C tokens goes in here, and it knows that account A has approved account B to spend those C tokens. Now, a lot of that's kind of abstract and maybe a lot at first, but we can jump into writing that code and doing it in a test-driven fashion, and hopefully that you can see, the examples and the tests and follow along. And also, in addition to those functions, we have one more event that we must implement. This is the approval event. This is a requirement. Anytime we call the approve function that we mentioned a minute ago, and anytime that function call is successful, we must trigger and log this approval event. And that's also something that we'll implement in this video. All right, so let's jump into building this delegated transfer. So just as a recap, we want an approve function. Sorry, let me pull this up so you can see it. We want an approve function. We want a transfer from function. I'm going to give it some space here. And we also want to build an allowance. And we need to build a transfer event. All right, save that for now. So the first thing that we want to build is this approve event. Now, in order to build this, we'll just sketch out this function. This will take an address. This will be the spender. This will give an amount, basically, of an unsigned integer. This will be a public function, be public visibility. And we will also specify the return value based upon the standard we just saw. It will be a Boolean. And you'll notice that this is a pretty common theme with these ERC-20 functions. We want a return value to know the result of the function whenever we call it. That's the same thing that we'll implement here. So let's just take a look here. So this approve function accepts an address of the spender and the value as an unsigned integer. So these two arguments represent the account that we want to approve to send on our behalf. So for example, if I'm account A, I want to approve account B. That's what I would, pass in here. This might be, the address on the exchange. And I want to approve account B to spend, amount C Dapp tokens with this function. And remember, msg.sender keeps track of the account that called this function. We saw that in the previous videos. And that's just function metadata that's going to get passed in here. So that's how we keep track of who is approving this. So msg.sender is going to be essentially, let's say, me in this case, and I'm going to approve this account to spend this many tokens. So let's go ahead and run a test. We'll give ourselves some space so y'all can see. I normally don't put extra space in my files like this, but I'm really just doing this for the tutorial so that you all can see the code at the top of the screen here. It's not really best practice, but just explaining why. So let's say it approves tokens for delegated transfer. And we'll pass it a function. And we'll say return Dapp token. Deployed. Oops. Then function. And we'll get track of the instance. Okay. And this is, pretty standard like we've done in every other test, token instance. Say return token instance approve call. This will be accounts 1. This is 100. All right, so let's explain this. So essentially, we are, taking our contract, our token contract, and we're calling the approve function with just this call here. Now, remember from the last video, if I'm, adding call here, this doesn't actually create a transaction. This simply, calls this function in Solidity without writing to the blockchain. So if I, do call from account 1 and 100 tokens, I'm not actually writing this data to the blockchain and changing all the data in our tests. I'm just doing it for this, small instance here. So we'll call then. And the reason I'm doing that at this point is A, so that we don't change the data, but B, I really just want to inspect the return value of this function. So based on our standard, right, we want this thing to return true. So let's go ahead and test for that. We'll assert equal, success. We'll say true. It returns true. All right. So let's run our test. All right, failed. Doesn't return true. It's what we expect, so we'll make it return true. All right. All right, passes. So let's go back to our standard and see, what we need to implement. We'll go to the approve function. All right. And so it allows the spender to withdraw from your account multiple times. And all right. So the approve function is going to build upon a couple things. we're going to handle the allowance, and we're going to handle the approve event, because that's what this says here. It sets the allowance, and also it triggers this approve event. Must trigger on any successful call to approve. So we'll build out the approve event first. We can do that like this, just like we saw this transfer event. We want to do an approve. Sorry. We'll say event approve. Again, if you missed this in the last video, events and solidity are just a way to, emit that something happened from a contract, and consumers can subscribe to these events, and these events are also going to get logged in the transaction logs. And we can also subscribe to events that we care about with these index values like from and to. So let's take a look at the standard and see what our event must have. So it must have an address, and this must be indexed. This is the owner of the tokens, and this is the address that must be indexed of the spender of the tokens, and this is the value, which is the number of tokens that are being approved. So let's do this here. We'll say address. This will be indexed. This will be owner. This will be another address. This will be indexed spender. And this will be an unsigned integer of the value. So this event's going to say that, I, the owner, account A, approved account B, the spender, to, transfer, C number of Dapp tokens. That's what this event, declares. So now that we have written that event, we want to add it to our function, but let's write our test first. So what we can do is actually call approve. So we want to say return token instance approve. We want to approve account 1. We want to approve 100. Now look, this is different from what we did up here. Remember I said that we used call so that we don't trigger a transaction, so that we can inspect the return value of this function and not modify any data. But here we do want to actually call approve. We want to create a transaction, mostly so that we can inspect the transaction receipt and dig into the receipt and find the logs. And we want to dig into the logs so that we can check for the approve event that it's going to be called or emitted whenever we call this approve function, like this. And we'll do something similar to what we did here when we check for the logs. I'm actually going to just kind of modify this and paste it in. All right. So let's see what's going on here. We want to inspect this transaction receipt. We want to ensure that it has logs. So there's going to be one log there or one event. We want to check it, and we want to say that it's the approval event. We want to check that it's got an owner. We want to check it that it's got a spender. And we want to check it to see that it has a value. So we can save this, run our tests. All right, fails. Oh, accounts. That's actually a spec problem. Let's fix that. It's my fault. It's a typo. All right, it fails like as we expect. So it did not trigger any events, and we expect it to have one. So let's go into our function and call the approval event. That's pretty easy. We just do that like this. msg.sender, spender, and value. All right, so let's kind of just look over this really fast. This is the approval event that we just defined here. Oh, sorry, approve. My fault. Approve event that we defined here. msg.sender, remember, is how we get access to the account that's calling this function. The spender is going to be the address that we are approving to spend our Dapp tokens. And the value is going to be the number of Dapp tokens that we are approving. So let's run our tests. Uh-oh. Event should be approval. And I think I might have misnamed this actually. Let's go ahead and check our standard. So this is important that we call things the right way. Because we want our token to be compliant. All right, so that's my fault, guys. I'm sorry. This needs to be the approval event, not approve. Sorry, I've done this 100 times, but kind of just made a little error there. So we want to call this approval. All right. So we'll go back to our spec. This is why you write specs, to make sure that your code is doing the correct thing. So it would be approval event. We'll run this test. All right. Could not connect to your Ethereum client. Yeah, guys, I'm glad we're actually running into these problems on the video, because these are the kinds of things that you run into with smart contract development. Let's check Ganache. Womp womp. So Ganache has crashed. Let's relaunch. All right. So you all might have experienced this before. This is pretty normal. Let's try to run these tests again. All right, they pass. Now that we've transferred the approval event, we want to really implement the meat of this function, which is going to be setting the allowance. We want to say, hey, this other account, this is how much they're allowed to spend. So in order to do that, we want to create an allowance. And that's kind of what we mentioned up here. Now, if we look at our standard, we can look at allowance. Oops, right here. And this is saying, allowance is a function that takes an owner and spender and returns, the balance that's remaining. This is the amount which the spender is still allowed to draw from the owner. So essentially, if we just set this balance with the approve and we try to read out of the allowance mapping, it's just going to return the amount of tokens that we just approved for, if nothing else has changed. So instead of writing a long form function here, like we saw in the standard, I'm going to just use a public variable. It's going to be a mapping, and this is going to be maybe a step forward. So if this is a little advanced, I'll break it down and explain it. All right, so let's break this down. So this is our allowance that we're building here. Allowance is a requirement that we have to implement, and this is just a state variable in Solidity with public visibility. And because it's a state variable with public visibility, we're going to get a getter function for free. So let's see what's going on here. So this is a nested mapping. So remember, mappings in Solidity are like associative arrays, or hash tables in other languages, where we have key and value pairs. This was just a one-dimensional mapping that we saw in balance of. It just takes an address and returns an unsigned integer. But in this case, we have a mapping within a mapping. Let's explain why. So essentially, I want to read this address. I want to say, if I'm approving the spender, if I, account A, am approving account B to spend C amount of Dapp tokens, I want to keep track of that in this mapping. So this key essentially says I would be account A in this case. This would be the key. I, account A, am approving account B, right? And I could, approve account D, account E, account F, account G, so on and so forth. So everything underneath this key would keep track of all of my approvals that I have, approved for transferring tokens. And that's what this mapping is in charge of. If I were to, like I said, approve account D, account E, account F, so on and so forth, this mapping would take this address and show how many tokens that I have approved, right? So in this case, it's pretty simple. I, account A, want to approve count B, right, in here to spend, amount C tokens. So this is a bit of a brain bender at first, but we'll write tests against this, and you can kind of see how it works. And maybe just take a second to kind of reflect on what's going on here if you don't quite understand it initially. So let's write a test to see that we actually update the allowance here, that we actually approve an account to spend tokens for us. And we'll do that like this. We'll add to this test here. We'll say return token instance, and we'll check the allowance, right? This allowance is the thing we just created. We'll check the allowance for accounts 0, and we'll say, did account 0 approve account 1 for some amount of tokens. Right? And we'll say assert allowance stores the allowance for delegated transfer. Right? So let's see what's going on here. We'll look at our tests. We said we actually created an approval, and we said we wanted to approve account 1. Let's actually specify the from account here. So we'll specify msg.sender. Otherwise, it was just defaulting to the account 0, but we'll be explicit. We are approving, account 1 to spend 100 Dapp tokens on our behalf. And this is, the value that's getting passed in as msg.sender. So down here, we want to check the allowance that our account, the one that sent the transaction, account A or account 0, actually approved account 1 or account B 100 tokens. So let's run that test. All right. So we can see that this was didn't pass as we expect. Let's actually call toNumber. It's probably going to yell at us here too. That's okay. All right, expect 0 to equal 100, and it didn't. That's okay because we didn't actually update the allowance mapping. So let's do that right now. So for allowance, we'll say allowance. This is just referencing the mapping that we created. We want to set the key of msg.sender. And we want to, update the nested mapping within that. So we'll call, spender. This is the argument that we're passing in here. And we'll set it equal to the value. Okay. Let's run our test. Boom, it passes.